taking one perfect bit of randomness as usual. So we're gonna start with the NeoGo department this time. We've made 3 significant releases of NeoGo in the past 2 months, with the latest one being 0.122.0. These releases mostly followed N3 protocol development. We have fixed a number of bugs in the protocol itself, and also there were some minor improvements there. Now, with the Gorgon hard fork enabled on all networks, we can say that all of these new features are available for blockchain users. We also have delivered a set of compiler improvements over all of these 3 releases. It was like one chunk in one release and another in another. And currently, I can say that we are pretty much satisfied with the state of the compiler we have in the latest release. We have improved support for some of the Go language features and fixed some bugs, and also have introduced support for some things that we have not supported previously in the compiler, like Go arrays, not to be confused with slices, of course, because those are different things. But the latest release in this series is a bit special, because there we have fixed a set of potential state differences with C# node, where we had some protocol mismatch in behavior of the C# node and Go node that could potentially result in some state differences, even though they were not known yet at the time of this release for mainnet or testnet. Still, if you are running a node, you should upgrade to avoid these potential problems that you can have otherwise. Most of our current blockchain department efforts are concentrated around the new hard fork for the N3 protocol, which is known as Huyao. We have already merged parts of the opcode pricing improvements that was announced previously, and currently we are completing the scheme with updates to native contracts and interop prices, because those are closely related to opcodes, and just updating opcode is not sufficient. Then we also have a prototype for the temporary storage native contract available here. I think it can be included into the Huyao hard fork as well, because the contract itself is rather simple. It allows you to store some things for some time, and it can be used to implement some time blocking or other features that require temporary storage. And this storage, which is very important, is auto-cleaned after some timeout that you can set for this particular storage entry that you are putting into this contract. This type of storage is also expected to be cheaper than regular one, because we are not growing the long-term blockchain state in this way, and we should encourage this behavior for contracts. Also, we're working on improvements for the hard fork mechanism itself. The proposal is outlined here, and it's going to be rolled out with the next 2 hard forks, because we need to introduce a new native contract method first, and then we are going to be able to use it. Overall, this will simplify hard fork management for users, because currently updating configurations, especially if you are maintaining a set of networks like mainnet, testnet, and also NeoFS networks, mainnet and testnet, is not really convenient to do and really error prone, so we are going to be improving that. And another interesting topic that we are planning to work on in the nearest future, but I would say it's more long term, because it's not going to be included into the Huyao for sure. We need to make some research first and really do a lot of testing before we are going to have enough data to make decisions on the protocol changes that we have ideas for. So we have this idea of improving the prepare request message in the DBFT protocol to include transactions to avoid the most common source of change views in real networks that don't have mempools perfectly synchronized, and which is the majority of the networks, I would say. This is relevant for both N3 networks and NeoX networks, for example, and all types of N3 networks like mainnet or NeoFS networks. So what we need to check here is how a relatively simple protocol change would affect performance, because we know that currently DBFT does not send transactions in prepare request as an optimization. And we know currently N3 networks can deliver really good performance. And if we are to change prepare request structure to include additional data, then we are not currently sure how this is going to affect different types of networks. So we need to do a lot of testing, and then we will either follow this proposal if it works fine, or we're gonna try to find some better solutions. Now on to NeoFS. In the past 2 months, we have made 2 significant releases of NeoFS, with the latest one available here. These delivered some substantial improvements to performance across a wide range of scenarios, but also some fixes and minor features as well. One of the new protocol features delivered in the latest release is the ability to set EACL right when you are creating a container. Previously, this was not possible, which left some gap, some time frame between you creating a container, doing an appropriate call and waiting for a transaction to get in and to be executed, and setting an extended access control list for the same container, if it's of course allowed by your basic ACL setting. So in this time frame, your container was using only basic ACL for permission checks, and usually it was too permissive, more permissive than you would like to. So most of the time EACL settings are done to restrict, and actually technically it could only be done to restrict. It cannot extend basic ACL. So currently you can do both settings, creating a container and EACL for it, in the same call, which I think makes the system more secure and more reliable. Another protocol level feature introduced with the latest release is the ability to use the so-called extended or HTTP-alike ranges for GET operations. It was always possible to take a range of the object and not the complete payload of it with NeoFS. Originally it was available via the range verb or range operation as a separate operations from the GET. Then we have optimized the protocol and moved it into the GET verb and operation, but just as a parameter. But semantically, it was always different from what was allowed by HTTP protocol. So when we were doing gateways like REST gateway or S3 gateway, we had to convert between the two meanings of ranges. And unfortunately, it required us to make some additional operations, because otherwise HTTP semantics allowed for some things that were just not allowed, that led to error in NeoFS. So we had to make a head of the object, get a header of the object from NeoFS first, then calculate the real offsets and the length of the object that we want to get from NeoFS, and then fetch it and then give it to the user. So this was obviously suboptimal. So currently we have moved the support for these extended ranges right into NeoFS, and this allows us to optimize our gateways. Two other things worth mentioning are removal of compression support from FS3, which just proved to be harmful, not really effective, and error prone. So you can decompress old objects that you have stored in FS3 with the current version, but you can no longer have new compressed ones. And in future, we of course are going to be removing support for it completely. So we provide a migration tool as well. And another thing is removal of the pull mechanism from both local shards and network operations. These have tried to be some crude load limiters that would throw off some excessive load on the system that system is not able to process. But over time, both have proved to cause more problems than they solved. It was really hard to configure them properly, and they were limiting the ability of NeoFS to scale on better machines. So we have currently removed them completely, and it all works fine. At the same time, we have plans for better replacement, but those are probably going to be explored and researched in some future. Another thing I wanted to briefly mention here is the work that goes behind the scenes but actually allows us to deliver NeoFS to you in a predictable manner and deliver all these new features and all of the protocol changes and all of the optimizations and not really break anything. And by this I mean the NeoFS test cases repositories. that has grown to contain more than 1,000 tests. This mark was actually touched about 2 months ago, but then as we have removed some of the older features, the number of tests has dropped because we have removed their respective tests as well. But we have added some new ones for both for old functions and also for new functions, and now we have some stable, really functional 1,000 tests that allow us to make NeoFS better. Of course, we have updated our NeoFS SDK with some new protocol features that we are delivering with the latest nodes. But more importantly, I would also like to mention that the new SDK available here also contains some SDK level optimizations both for object readers and object writers. So if you are to just upgrade SDK in your application using NeoFS, you're gonna have better performance than before. So please follow and upgrade and have better performance with the new SDK. Currently, we are gradually introducing TLS-specific optimizations to the protocol because using TLS secure connections basically allows us to optimize out some of the signatures we have in the protocol. While we have already done a lot of optimizations in this area, we are using TLS for both mainnet and testnet, and this solves the same problems at the different level. So we are going to be improving our support here. Also, we are currently exploring ways to decouple epochs from network map. And I think it's going to be implemented in the nearest future and in the next version of NeoFS actually. We want to have a system where if nothing changes, like the network map, and it's mostly static in most networks most of the time, and really changes rarely. So we want to have a system where when there is no changes in the network map, nothing really happens. Currently, that's not the case. Every epoch triggers some actions from nodes and inner ring. And that's a lot of actions happening at the same time. So this also creates some load spikes for our blockchain components, for example, and that's not really appropriate in a distributed system because when we have just 5 nodes, that's not a big deal. But if you have 500, then all of them go into the same RPC is a problem. So we don't want that. And also we're going to be exploring container level versioning because originally, NeoFS containers were immutable, but now as they can be changed in some ways, like they can have some attribute changes, these attribute changes can affect applications. So for applications, it becomes important to have some counters, some versioning for container to know if they are up to date with their understanding, their basically view of this container. So we're going to be implementing that in some future as well. The latest REST gateway is available here, and it includes improvements in attribute handling and also some bug fixes, as well as some performance optimizations as well. It will soon be replaced with a newer version because we have not yet updated with the latest SDK and the latest feature of the NeoFS protocol, but we will soon be doing that. So please follow our announcements and upgrade your REST gateways. Currently, I know for sure that some of the gateways that we have in the network were not upgraded. We just know that because we have a lot of range requests that we should not have currently with the latest gateways. So please stay up to date. A big cleanup of the S3 implementation was delivered in the gateway version 0.45.0. It removed some of the old deprecated code and functionality and streamlined some of the flow for object operations. So we're pretty much satisfied with it now and we think it works fine. We don't have any plans for new S3 features at this point, but we will be doing some performance optimizations there